Okay, let's discuss about normal distribution. It is an extremely important continuous probability distribution. It arises very frequently in theory and practice. Normal distribution, which is also called Gaussian distribution, the most common distribution function for independent randomly generated variables. Here is a simple plot of normal distribution. On horizontal axis, we can see the that we have a variable x, and fx is what we call the probability density function pdf, which gives the height of the curve at the point s. And here is the equation for the probability density function of the normal distribution. We can see here two parameters, mu and sigma, and the random variable x. First of all, the random variable x has a normal distribution. Then it can, if the random variable x has a normal distribution, then it can take any values. And there are two parameters for this distribution, as I have said before, mu and sigma. And mu is the mean of the distribution, and we can take any finite values for it as well. And the mean can take on any finite value, and sigma is the standard deviation, and sigma squared of the curve is the variance, and sigma has also some positive value. And the graph of the normal distribution is characterized by two parameters, as I've said before, the mean or mu, or the average, which is maximum of the graph and about which the graph is always symmetric, and the standard deviation, which determines the amount of dispersion away from the mean. And here mean is like the mean is represented by mu, and which is the middle of the distribution, and the distribution is symmetric about mu, so mu represents the mean of the probability distribution and also the median of the probability distribution. And now let's try and get some perspective for what sigma represents. We have here sigma, which is nothing but the standard deviation, and here is the plot with the one standard deviation when the sigma value is equal to 1, and we get the we can see here when we have a standard deviation 1 below the mean, and standard deviation above the mean. We can see like here the point which is indicated by this dot line, and the area between one in the standard deviation, below one standard deviation, and above is approximately 0.68 or 68.3% of this total area is covered. And here again, if we plot with the sigma minus 2 standard deviation, 2 sigma plus 2 standard deviation, and approximately here 95% of the area lies within the 2 standard deviation of the mean. We can see here the area of coverage is around 95%, and approximately 99.7% of the area lies within the 3 standard deviation of the mean. Like we can see here, from minus 3, when the standard deviation is around minus 3, from mu to plus 3 of the when the standard deviation lies minus 3 to plus 3, then we get 99.7% of the area coverage. So here gives another plot to give us the little perspective of what sigma represents. Here we can see that the gray line represents the normal distribution with the standard deviation of 2. Sigma is equal to, when it is 2, and the black line represents the normal distribution with the standard deviation of sigma when is equal to 1, and so the standard deviation of the gray curve is double the standard deviation of the black. And there is the area of in the tail and the lower peaks, and so there is not infinite number of normal distribution that we can represent, and when corresponding to all the different possible values of mu and sigma. And if we have x as a random variable, like if we have x is a random variable that has a normal distribution with the mean mu and the variance sigma square, and we write this as the random variable x, it is distributed normally with the mean mu and variance sigma square, and x is normally distributed and x is distributed normally by n, big N, and the first term is the mean and second is the variance. And by definition, the standard normal distribution is the normal distribution with the mean mu is equal to 0 and variance is 1. And we often represent the random variables that have the standard normal distribution with the letter z. And we can say here like the z follows n with the 0 mean and 1 variance. And finding the probabilities and the percentile of the normal distribution requires the integrating of the probability density function. Here we have got fx is the probability density function, and the probability that random variable x takes on values inside the interval of a and b is given by the integral of function fx ranging from a to b, which gives the area under the curve. As we have said before, like this we are talking about the continuous distribution or continuous random variable. So we while taking the probability of the random variable or finding the probability, we take in the range of the, or we take in the interval of two values. Here in our example, like we have got the p is in the range of a and b. So it's about the basics of normal distribution. And in our next class we will be discussing about some hypothesis testing and other topics on the big data analytics.